Thank you. I also want to thank that I'm able to talk here, and I'm second time here. I think last year I promised I will try to make such presentation in Russian. Please give me one further year, and then I think I can do it. What I want to talk today about is relevance of different battery technologies for storage applications. And what I want to say, in the last 12 months there were a lot of development of these batteries. We hear also some new battery technologies appeared, and we as an inverter manufacturer, we are of course looking on these developments. And what I want to present a little bit how we see the battery world. We do not produce batteries and we do not sell it. So, but what are our expectations? I will shortly show where are possible applications of storage solutions, what kind of battery types and suits for which application, and I will show you some references. I will not talk about Tuyonari today. What are the challenges for energy storage? The growing installed base of renewable energy causes fluctuations in the energy demand, and we had also we heard about that there need to have solutions for storing. At the end, the challenges are we have we need a flexible grid integration and grid services. We need to management backup power capacities, alignment of power consumption and production, and we need to secure the power supply and the grid quality. What are the benefits from the solutions if you take care about this? You make renewable energy dispatchable, not only PV plants. You can reduce the capacity of backup power plants. You can maybe avoid the expensive rollout of new transmission lines, and you still secure the power quality. You can stabilize distribution grids, or you can increase the self-consumption. Just where we see applications in the whole grid system. Here's a short example of high voltage and medium voltage grid, just as an example. You have the conventional power plants there, you have maybe renewable power plants, you have large commercial loads, and you have of course other various loads. So you can integrate battery stuff for black start capability of conventional power plants. For renewable integration, for shape, at the end, for make the output of renewable energy plants to put only on one level for better regulation. For power quality, peak shaving on large commercial loads. Grid services, delay of grid extensions, and frequency control. And of course, also on the low voltage grid side, you can regulate the home management system or local produced energy to use on the right time when you produce the energy. So we have a wide range of different applications all over the grid for such solutions. It's from large to small capacities. It's about frequency and voltage regulation, spinning reserves also, and that's why I'm also here, about hybrid solutions, off-grid solutions, for community social transmission and distribution, transfer, energy shifting, also UPS. So there's a wide range of possible applications for battery storages. For the different storages or applications, you have different requirements. For instance, in the residential, in the on-grid residential area, you want to increase the storage, the self-consumption. In off-grid residential commercial applications, you want to have a secure supply, a secure energy supply. In industrial on-grid applications, the grid support and the energy is the most important. And in the off-grid area, you want to decrease with battery technologies, decrease the fuel consumption, increase the fuel savings. Shortly about the battery types which we are currently see as a manufacturer, which have potential, which are currently also already commercialized and which are on the market and which are a more or less proven technology. We currently see some high temperature batteries and the low temperature batteries. For high temperature, the natrium sodium sulfur batteries and the sodium nickel chloride batteries. On the low temperature side, the lithium ion batteries and the lead acid batteries. Just some information how they are, some basic technical data in fact. Also the cost and cycle lives, I think you can read. The temperature needs, for the high temperature batteries, the major problem is you need to maintain a high temperature of the battery. It's the second technology. Then the low battery temperatures, the lithium-ion batteries, one of the major disadvantages from our point of view is that you need an additional battery management system and you have to supervise each cell to avoid short circuits and further damages. So you have additional parts in the system, additional parts in a off-grid area means you need service. So there are some risks, especially for really remote locations. Lead acid, I think this is the most best known technology. We need all the disadvantages of this. Of course, they also have advantages. If you're looking on the different applications, we see, and this is at the end my message today, for self-consumption increase, we see at the most suitable battery technologies at the moment the lead acid and the lithium-ion technology. For the storage application, for the off-grid applications, we currently see lead acid, lithium-ion, and some flow technologies, which are maybe the most suitable for this application. For grid support functionalities or grid support applications, we currently see the lithium-ion as the most important technology. And for energy shifting, you can use more or less all the technologies, battery technologies which are available. For diesel hybrid stations, which are working also without, where you attach battery inverters to decrease the spinning reserve, we see the best battery systems will be consist from lead acid or lithium-ion. Just shortly showed you that this is nothing really new. These are some examples of projects which we did worldwide with large battery inverters. The market is going up. For instance, this is an off-grid system in Tonga. It's a 500 kV PV installation. The island is completely sourced by solar energy. A 1 megawatt battery system also in the Pacific Ocean on the island Tokelau was one of our last projects. So my conclusion is you should take care about, you have different battery technologies with advantages and disadvantages, and you have different applications for storage technology, for off-grid, on-grid, on different levels. And you should choose always the right battery technology for the right application. That was it. Thank you very much.
Well, Jan, thank you very much for making my job easy and being the typical Deutsche Punktlichkeit that you respected today. And this gives actually the opportunity for a bit more questions. Are there any questions from the audience to Jan? It seems that you have been crystal clear. Any audience, any questions from my colleagues on the panel? Well, this is a private issue which I let you decide between the two of you in German. No questions? Then I will allow myself one or two questions, Jan. First of all, what have you done to date in Russia?
What I have done in Russia, I made a lot of business trips to this country. I trained my Russian. Let's say it on another way. From my point of view and for my company, the hybridization of the Russian diesel gen stations is a strategic market, and I try to work on this with the best what I can doing. because I think we have the right technical solutions for this hybridization. Okay, we are focused on solar, but we are also able to integrate wind energy. So this I'm doing in Russia, and I try to give to my clients the best support which I can give.
Thank you. Then maybe a similar question which I asked Mark. What would be your advice to the operators of the local energy systems and to the local administration for moving faster towards the de-dieselization, if I can call it that way, of the current installations in the remote areas? And I know it's a tricky question.
It's very simple. Simple, believe us, it works. We know it, we do it for more than 10 years, it works.